All right. Hello, everybody. We're going to look at section 2 of chapter 2. This is going to be more stuff on equations of lines, kind of following up from what we were doing last time. So, come on, computer. All right. So we're first going to look at graphs of linear functions. And so for this first example here, what we've got going on, they say graph y or graph f of x equals negative 3/4 x plus 6. Do that by plotting points. So essentially the way you would do this is you would pick some values of x and plug them into the formula and then see what they give you. So to start with, I'll pick the number 0 because 0 is always easy to calculate with. And we'll see what f of x or y value that will give me. So we're going to do negative 3/4 times 0 plus 6. Fun fact, negative 3/4 times 0 is just 0 plus 6, which is going to give me 6. So the point 0, 6, here's your x-axis, here's your y-axis. So we're going to go 0 on the x, and we're going to go up 1, 2, 3, 4, 5, 6. Go up 6 spots on the y-axis. That's going to put us right there. The next number I'm going to pick, I'm actually going to skip ahead to the number 4. The reason I'm doing that is because the denominator of this fraction also happens to be 4. And, you know, I can do fractions, but they are kind of a pain sometime. But what you will notice, if we put in 4, that will just cancel out with the number that's down below. And the only thing left will be a negative 3 plus 6. So it just makes our lives easier. Negative 3 plus 6 happens to be the number 3. So then what I would need to do is go to the point 4, 3. So I'm going to go over to 4 on the x-axis. 1, 2, 3, 4. Go up 3. 1, 2, 3. And that'll put me at that point right there. And then what we do is we go ahead and draw a straight line here. And there you have it. You have successfully drawn yourself the graph of that line. And again, I'm assuming this is kind of review for many of you, but one strategy for drawing a graph of a line would be to just pick x values, plug them into the formula, and then see what y value that gives you as a result. Now, there's an alternative way to do this, and this is probably a method that's maybe more familiar to many of you. So what they ask us to do here, they give us an equation of a line. They want us to use the y-intercept and the slope. So what's going on here, the formula is y equals mx plus b. B is the y-intercept. That's where you're going to start on the y-axis, which is the one that goes up and down. The x-axis goes side to side. So what you will notice in this problem, B is the value 5. And then meanwhile, we've got negative 2/3 here. M is going to equal negative 2/3 because M is the slope. And fun fact, negative slopes go down and left. So they're going to go like that. Positive slopes, for what it's worth, go up and right. Or, I'm sorry. You're going to go down. You're going to go down and to, I'm sorry, down and to the right. They both go to the right. So negative slopes go down and right. So you go down and then right. And then positive slopes go up and right. So essentially what's happening, we're going to start at 5 on the y line. So you go 1, 2, 3, 4, 5. It's going to put you right there. And then negatives are supposed to go down and to the right as opposed to up and to the right. So from that point, this is going to tell me to go down to, that is the rise, the top number, and then the run is the bottom number, which is 3. So I'm going to go down 2. That's what the -2 tells me to do. And then I'm going to go right 1, 2, 3. That's what the 3 tells me to do. And when I do that, that will give me this point right here. And then you draw the line like so. And there you have it. There's a very lovely equation of a line, or a graph of an equation of a line. The x-intercept, that's where it's the value of x when f of x equals 0. And it can be solved by the equation 0 equals mx plus b. So the y-intercept comes from where x equals 0. And the x-intercept comes from where the y value equals 0. So basically, the name of the intercept tells you that the other variable should be a 0. It comes from y equaling 0. And as an alternative, that's f of x equals 0. Anytime you see y, that's basically another way of saying f of x. So basically what this means is they say find the x-intercept. You're going to set the equation equal to 0, and then do a little bit of algebra here to solve that and find what number that gives you. So since we are subtracting 3, the first thing we will want to do is add 3. So 3 equals 1/2 x. If you want to get rid of a half, you need to multiply by 2. You want to multiply the reciprocal if you want to get rid of a fraction. So essentially you need to multiply by 2 over 1. That's how you can get rid of a fraction. Fun fact, 2 over 1 is really just exactly the same as 3. So 2 times 3 is going to give you the number 6, and that tells you the x value, which is x equals 6. Now, the x-intercept is a point, which means it is supposed to be coordinates x comma y. We have an x value. The y value that goes with it is just 0, because that's what we put in the first place to obtain the 6. So when you give an intercept, make sure that what you're providing is the coordinate of a point. You start with either, if it's a y-intercept, you start with an x is 0. If it's an x-intercept, you start with a y is 0. And then you just either plug in values and solve the equation. That will find the other number that goes with it. And your final answer is a point, because an intercept is a point. The x-intercepts are on the x-axis, the y-intercepts are on the y-axis. That's part of where they get their name. It tells you which axis the point is on. So lines can be either horizontal or vertical. A horizontal line is going to look like this. F of x equals b. That's what horizontal lines will look like. This right here is a picture of a horizontal line there. If you have a vertical line, the formula that will give that is going to be x equals some number. We're just calling it a to call it something. Here, what you will notice, this is at -4 right here. This is the y value. So if you're going to write an equation for this graph, that just means f of x should equal -4. And then because it equals just a number, there's no slope, there's a zero slope. A zero slope means you're flat, much like the part of Illinois where I'm from. It is just completely flat. There's no skiing to be had there. We're about to have a snow day tomorrow, and in Illinois, those were really super lame because there weren't any decent hills to like go sledding on. But anyway, I digress. The point is, that's a horizontal line. F of x equals -4. Here we have a horizontal, or I'm sorry, this one's a vertical line. So because this one is vertical, the equation is going to be x equals some number. Now, what's the number going to be? Well, here's 6, here's 8. So halfway between those is going to be 7, yes? So if we're going to write an equation for this line, we're going to say x is equal to 7. There you go. That wasn't so bad, hopefully. All right, what else do we have going on here? So then we have parallel and perpendicular lines. So the definition of lines that are parallel, they are going to, they do not intersect, and the slopes are the same. So basically, if they keep going up and over by the same amount, they're never going to cross. They're never going to meet each other. So slope number 1, M1, that will be equal to slope number 2, M2. If the intercepts happen to be the same, the lines are actually going to be the exact same line, which is different than being parallel. But so long as they have different intersection point, the different intercepts, different y-intercepts, if the slopes are the same, those lines are going to be parallel. For perpendicular lines, they intersect at right angles, so they make a 90-degree angle where they cross. And so basically, if you flip the fraction over and change the sign, that is going to give you perpendicular slopes. So for instance, if I start with a slope 1/4, the negative reciprocal of 1/4 is going to be -4. If you flip over 1/4, you get 4/1, also known as 4. So if you flip this over, this is going to be -4/1, which is really just -4. So you have to do the negative reciprocal. For the other one, if I start with -4, you switch it over to a positive, and then to get the reciprocal 4, that is 1/4. So you have to do the reciprocal, you have to flip the fraction over, and then you have to change the sign. So you do negative reciprocals, that gives you slopes that will be perpendicular. So here they say, given the functions below, identify the functions whose graphs are a pair of parallel lines and a pair of perpendicular lines. So if we start with f of x, m is equal to 2. And if we look at this, what you will notice is that for j of x, that also has an m equal to 2. So the value with the x, that is going to be your slope right there. So those both have 2's. So that means that those are going to be parallel because they have the same slope. So F and J are going to be parallel because the value of their slopes is exactly the same. Meanwhile, if we look at the other option here, so here we have positive 1/2, here we have -2. If I take 1/2 and do the negative reciprocal, that's going to be -2/1, also known as -2. So that basically means that G and H are perpendicular. And the reason that that is the case is because they are negative reciprocals. All right, so that is that one. Let's see what else we have. So given the functions below, identify the functions whose graphs are a pair of parallel lines and a pair who are perpendicular. Why does this? I have a feeling that's the exact same. That's the exact same example. All right, let's delete this, shall we? Let's see. Let's do something different. Let's see. So find the equation of a line perpendicular to 3x plus 3 that passes through the point 3, 0. Okay, so how would we go about this? So first off, let's look at the slope. So the thing to notice is that the original slope, which we will call M1, the original slope is 3. We need to do the negative reciprocal. Let's see, that is not how you spell reciprocal. Negative reciprocal. Reciprocal. There you go. All right, negative reciprocal. So what do? You say M number 2 is going to be equal to negative, positive goes to negative, 3, if you do the reciprocal, is 1/3. So the number we want for the slope is this right here. So then we had a formula that we were talking about last time. This is a very handy formula to have at your disposal. Y minus y1 equals m parentheses x minus x1. Let's see. So here, from this point, x1 is equal to 3. And from this point, y1 is equal to 0. So then we're going to say, okay, this is y minus 0 equals -1/3 times x minus the x value, which is 3. We will break out our friendly neighborhood distributive property here. See what that gives us. This is y equals -1/3 x. And then this will be -1/3 times -3. See, 2 negatives is going to give you a positive. And then 1/3 times 3. 3 will cancel with 3 and leave you with just 1. That's -1/3 x plus 1. So there you have it. That is the equation of a line with that point on it that is perpendicular to the original one that they gave us. Okay. Here they say, given the function h of x equals 2x minus 4, write an equation for the line passing through 0, 0 that is parallel and that is perpendicular. Okay. So for parallel, we basically want M1 to equal 2. And for perpendicular, we want M2, the second slope, to be negative 1 over 2. We're going to use x1 as 0, and we're going to use y1 as 0. And like before, the formula, know it, love it, use it all the time. Y minus y1 equals m times quantity x minus x1. So we're going to do, let's see here. This is part A. We're going to do y minus 0 equals 2 times parentheses x minus 0. The zeros aren't really going to do much, so this is going to be just y equals 2x for the first one. For part B, we're going to do y minus 0 again. This time we do negative a half for the slope, and then x minus 0 right there. Again, multiplying with zeros and adding and subtracting zeros isn't going to do a whole lot. This will just be y equals negative 1/2 x. Okay, and it looks like we got one left. A line passes through the points -2, -15, and 2, -3. Find the equation of a perpendicular point, a perpendicular line that passes through 6, 4. So we want something perpendicular. We have a point that tells me x1 is 6 and y1 is 4. And what I need to do is I need to find the slope of those 2 points that I have originally. So let's see. So if we're going to do the slope, we're going to do -3 minus -15. This is M1 incidentally. Then what? We're going to do 2 minus -2. -3 minus -15, that's -3 plus 15. 2 minus -2 is 2 plus 2. -3 plus 15 is the number 12. 2 plus 2 is the number 4. Divide that and you get a 3. So M number 1 is 3. They tell me they want it to be perpendicular, which means I need to change it to M2, which will be -1/3. You have to do the opposite reciprocal. Okay, so what we will do is we will say y minus the y value, which is a 4. That will equal -1/3, and then parentheses, you do x minus the x value, x minus 6. Let's see, let us do the distributive property on this. And you get y minus 4 equals -1/3 x. And then you need to do -1/3 times -6. That will give you positive. The 6 will divide the 3 and leave you with 2. 1 times 2 is 2. And then we will add 4 right here. And so when all is said and done, we will obtain y equals -1/3 x plus 6. So there is that one for us. And that is the end of the first section. So let's stop there for now. And let's take ourselves a short break.